Hello everyone. So today we'll be seeing the question maximum sum combination from the heaps playlist. So yeah, we've been given input as two integer arrays called A and B and they're of equal size. And the sum combination is formed by adding one element from A and the another element from B using each index pair A, I, J at most once. So this means that if I have, let's say, two arrays, 1, 2, and 3, 4, 5, and 6. If I have made the sum of 1 and 4, that is 5 once, I will not be using it again, right? And we have to return top k maximum sum combinations sorted in non-increasing order, right? I hope the problem statement is clear with everybody. Let's just see through an example statement. This input, considering since it's a larger input, I'll be doing it with this one. So we have A as 1, 4, 2, 3, and the another one as 2, 5, 1, and 6. Right? So first thing, let's just have each from here, from each from here. Let's just calculate 1 plus 2, then 1 plus 5, 1 plus 1, 1 plus 6, then 4 plus 2, 4 plus 5, 4 plus 1, 4 plus 6, same for 2 and then for 3. So what is the complexity for the same thing? We'll be doing this in O of n square because just imagine this how we're doing it. We're using one for loop that is iterating over the A vector and then another for loop that is iterating, that is a nested for loop iterating over the B vector, which gives us the complexity of O n square. Now this is not the end of the question, right? So now whatever we've received, we have to sort it off. Now let's say this is my answer array. I have to sort this answer array and then return the first k elements, right? And then I have to return, or I can say I have to return answer array from index 0 to index k minus 1. Does that make sense? So what is the sorting going to take the time complexity? So how many numbers are we going to get from here? So basically we're going to get n square combinations. So now the number that was n earlier has become n square. So what will be the sorting's complexity? N square log n square. So what are we going to have? O of n square plus O of n square log n square. That means we're approximately going to have O of n square log n square as the time complexity. Does that make sense? And space complexity of O of n square. Because this entire array that we're going to use, right? Does that make sense? Okay. So now let's just do this using heaps because this is a little too much time complexity. Make sense? Okay. So this was our approach 1. Now let's just go to approach number 2. Okay. I will just copy out the input from above that says 1, 4, 2, 3, 2, 5, 1, 6. So I have the input that goes by 1, 4, 2, and 3, and another array that goes by 2, 5, 1, and 6. Right? Okay. What if I sort my arrays? Right? What if I sort the array in and then say 4, 3, 2, 1. And I also sort this array and make it 6, 5, 2, and 1. Does that make sense? Now I know for sure that my answer vector, let's say this is my answer vector. The first entry is going to be what? The first entry is going to be 4 and 6. 6. For sure, right? Now, if I keep pushing the values inside my heap and then keep popping them for k values, do you think I'll get the answer? I will get the answer. But now then I think, why do I have to push all of them together? Right? And since they have mentioned right here, ij at most once, I will have to use a set. This set, let it be visited set, is going to tell me if an index pair has been visited already or not. You will understand this question as we go into it, as we go into the approach, has been visited already or not. Make sense? Okay. So now we have this as our input array. And what are we going to do on this? Let's just see. So if I take a priority queue, right? This is my priority queue. And what will be this? Max heap. Makes sense, right? And then this is my set. So my set is going to take elements in x comma y format, and my max heap is going to take elements in what? Value x and then y. So now let's just index it off quickly. 0, 1, 2, 3. Right? So I have in my max heap something as 10, 0, comma 0. Right? Now the other value that is going to come in, first is 4 and 6. Second could be 4 and 5 and 3 and 6. Make sense? Yes. And after that we can have 8. Right? So how do we do this? How do we do this crisscross action? If I had to do one from here individually, 4 and 6, 3 and 5, it was easy. I would just have iterated over 1, taking the element from the other index, same, O of n, right? But here I have to account for this crisscross as well. So what do? I take in 0 and 0, and then I check, has 0, comma 1 visited? And then it says, no, it is not visited while I have 0, comma 0 in my set. Right? So another time if I try to check 0, comma 0, it will say no, you have already visited it. You cannot put its value again in your queue. So the first value I have in queue is 10, right? And then I'm going to take this 10 and push this into my answer. Right? Make sense? How many values are we going to see? Let's say, what is the k value given to us? We have k as 3. Okay. So we need 3 values. Now 10 is already, let me take k as 4. Okay. Okay. So I had 10. Now I will just pop this off. What was my x value? 0. What was my y value? 0. Now I will check, is x and y plus 1 existing in the set? Is 0, comma 1 existing in the set? It will say no. So what I will do, I will calculate 0 and 1's value, that is 9. Right? And here I will put 0, comma 1. And here I will put 0, comma 1. And then in the same step, because I don't know, 4 plus 5 can also be bigger and 6 plus 3 can also be bigger, right? I don't know. But I know one thing for sure, that 4 plus 5, this I've made so, okay. But I know one thing for sure. What is that one thing? That 4 plus 5 is always greater than 3 plus 5 or equal to. But it is greater. But it is never smaller. Why? Because 4 is greater than 3, simple maths, right? Here it could have been 4. Then it could have been equal. But I know one thing for sure, that 4 and 5 together will be greater than 3 plus 5. But the confusion is where that 4 and 5 could be greater or could be smaller than 3 plus 6. So these two cases I have to take together. I have to take simultaneously and put them in the heap, and then heap will decide which one I have to take first. So I cannot pop this off straight away. I have to also put in heap 9 with the value as 1, comma 0. Are you getting it? Right. So I also checked in for x plus 1 and y. Now I have this, another step comes in. What will get popped off? Anything. It is how you decide what you're going to pop off. So let me say I popped off this. Now what is it? 0 and 1. Right? So I just pop this here. I have 0 and 1. What will it check? X and y plus 1. Is 0 and 2 visited? No. So what will happen? 0 and 2 will come here. 0 and 2 will come here. And what is it with 0 and 2? 0 here and 2 here. It's 6. right? Then I will also check with x plus 1 and y. That is 1 and 1 and 1. So 1 and 1, it is what? 8. And I will also mention 1 and 1 has been visited, right? Another turn. What will get popped off this time? We will pop off this. I have again 9 here. Now 1 comma 0. What will first happen? X and y plus 1. That is 1 comma 1. Now the set will say 1 comma 1 has already been visited. So I will just ignore this step. I will not do anything with this. Then what? 1 plus, what did we have? 1 comma 0. 1 comma 0 was the parent thing. Now we will have 1 plus 1, 2, 0. 2 and 0. That is 2 and 0. 2 plus 6, 8. Make sense? 8, that is with 2 comma 0. I will have this also. I will have this here also. Make sense? Another step. What will get popped off now? Let's say 8 with 1 comma 1 is getting popped off. What will get into here? 8. And once this has already reached its size of k, we will stop. Make sense? Now let's just fast forward to the code part. I'll write code part out here. And then we'll quickly see the time complexity before I forget telling the time complexity thing, right? So what are we going to return? We're going to return a vector of size k, which doesn't even matter here, but okay, I'm telling you that vector is going to have the size of k. Vector int maximum sum combination. I have mentioned this before a lot of times that please give genuine names to your variables, right? So that it increases your code's readability part. Then we have vector int a given to us. We also have vector int b given to us, and we also have an integer k given to us, right? This is all we have got. Makes sense. Now we need a max heap. Priority queue int. What are you going to have? Priority queue pair. Pair of what? Int. And pair. Pair of what? Int comma int. Max heap. So basically what is it? I will use green for the comment section. This is for the comments, val. And what is this? This is your x and this is your y. X is from your first array, y is from your second array, right? Make sense? Okay. Now let's just go to next thing that we have. We have a set here. I can define unordered set. That is again going to be a pair of int comma int. And I'll call it set. Make sense? Okay. What next? I'm going to sort these A and B. In what order I have to sort them? I want to sort them in descending order. We know how we sort them in ascending order, but how do we sort them in descending order is the question. How am I going to sort them? See the syntax properly. So you'll write sort. You will write A dot begin. You will write A dot end. This is how you generally do the sorting part. But if you have to sort in descending, what do you write? You write vector, you write int, you write greater, you write int. And this is the comparator that is used to sort your array in the descending order. Same thing, but for B. B dot begin, B dot end, greater, end to sort it as well in the descending order. Now we know one thing for sure. What will the priority queue? Let me mention priority queue here. What will your priority queue at first have? Your priority queue at first is going to have A of 0 plus B of 0 for sure. Make sense? And 0 comma 0. Make sense? All right. And then your set is going to have, we insert in set. Okay, remember this. 0, comma 0. Set you can call it visited. All these are the names for it that go well. Okay. Now that we have all this, we have priority queues data, we have sets data. What next we have to do? We have to check while k minus minus. Okay. And then we have in priority queue our values. We have value in set. So what I'm going to do, I'm going to write int val is what? Priority queues top dot first. Int x is what? Priority queues dot top dot second dot first. Then we have y. Y is what? Priority queue top dot second dot second. Make sense? Right. Now what I'm going to do, I'm going to priority queue dot pop. And what I'm going to do, I have to define an answer vector. So I'm going to define here vector int as my answer. And then I'm going to push this value into what? Into my answer. Answer dot push back as my value. Make sense? Okay. Now let me just write straight. It's going a lot vertical up. So yeah, answer is done. Now I have to check if x plus 1 is less than a dot size, right? And set dot find. Set dot find what? Set dot find x plus 1 y is equal to n. That means you did not find this pair. So if you did not find this pair, what are you going to do? You're going to push this pair into your priority queue. How are you going to push it? A x plus 1 plus b y along with x plus 1 y. Make sense? And you're also going to insert this into your set. Make sense? Okay. Then if my y plus 1 is less than my b dot size and set dot find x comma y plus 1 is equal to set dot n. That is, you did not find this in the set already visited. What are you going to do? You're going to priority queue dot push ax plus by plus 1 along with what? X and y plus 1. And then you're also going to insert the same thing in set, telling that, okay, this is visited for now. Do not visit it again. Make sense? Make sense. And then in the end, what are you going to do? You're going to return your answer vector. Let's come to time complexity part now. Let's come to your time complexity part now. Right, time complexity part, we do sorting. And for sorting, we know it is what? N log n. Right? Then for every insert operation, we have it as log m. But how many can we do at max? What is the worst case? We can do n operations. So what is this going to be? N operations, and each operation takes time of log n. So this is your total. That is approximately n log n. Make sense? Okay. And then your space complexity. For space complexity, you have a set that cannot go beyond what size? You have a set that cannot go beyond your size of what? Each value taken once. If you've taken the value again, you cannot do this. So this is the set cannot go beyond n square. Makes sense? Then we also have a priority queue, and then we have an answer vector that cannot go beyond k. So basically your the space complexity, that is for the answer has to take k space, right? So we can have it as k. And then we also have priority queue, which at max is going to have just 3 values. At max 3, right? We took this, I remember, right? At a time you can have, actually at a time you can only have two in the priority queue. So it does not even count it off. It's just a constant one. With this, thank you so much. Bye-bye. If any doubts, please post them in the comment section. You can also use the G-forms attached for any questions you want me to take, even if they're outside heaps topic. And yes, thank you so much. Bye-bye. If you could extract anything out of the video, if you found the video to be helpful, go just hit like and subscribe. Thank you. Bye-bye.